be aware that when we do introductions, I'm going to pause it. So you should hear it stop recording. Okay. So module 0, course introduction. Let's get it. Okay. First things first. This course is designed to give you some measure of practical experience when it comes to machine learning, particularly as it relates to SageMaker, which is got a bunch of subservices underneath it, like Ground Truth, which is a labeler, lifecycle configuration, which allows you to boot your kind of like model training instances, right, and configure them as you see fit instead of having to manually do it. So you're going to learn how to use the ML pipeline to kind of guide you through these like practical ML problems and how to use SageMaker to build ML solutions. I just want you to be forewarned. You know, this class, if you're not a data scientist, data engineer, and you're new to ML, it's going to be a lot of information. Please take notes. You're going to have access to recordings. Please do not get don't allow yourself to get overwhelmed. If you're new to this, it's just going to be a lot of information and you're going to take it in and it's going to be your first primer, right? To getting exposed, right? To ML. So if you're an experienced like data science, you get a PhD in mathematics and you've been doing this for a couple of years, you're really just here to learn how to use SageMaker. You're not really here to use ML. And so, you're going to see a blend and a mix of experiences. I've had classes where, people like have zero data science exposure, zero machine learning exposure. And I've got some where people are like, yeah, I've been doing this for 10 years actually, right? Or however long. And so I think I actually worked with my first data science team, ML team in, 2013, actually. So yeah, almost 10 years ago. So 9 years ago. So, be aware that there's going to be a wide range. We do tend to work as a group in this course, but the idea is that you know more than when you came in, either about how to use AWS for machine learning or about machine learning and AWS services. Okay. Now I'm going to feel that out in just a second. And I want you to know the best possible place you could be in is this class is really designed for beginners, honestly. Now you may have noticed, you're like, Michael, why do you say that? Like, it's like a machine learning pipeline. Just to say this is that, remember back here when we were looking, you may have seen briefly all the like groups of classes that I have available to me that if I'm certified that I could possibly teach to you all. I just want to point out a couple things. This is one of many machine learning classes and, classes of that type they have. So I'm going to point out is that you can see all these classes as far as like discovery days and blah, 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 blah. But big data used to be the course on this. And they retired the big data certification. And of course, we don't really use the term big data anymore. I mean, we kind of do. It's kind of just like assumed that everybody's doing some kind of like insightful and meaningful pattern finding inside of their data, right? If they're not, they're probably becoming irrelevant. Then we've got other things like building data analytics and building data lakes. Notice though that there's a data science with Amazon SageMaker. So there's like a deeper kind of data science discussion. There's another class, right? Beyond the machine learning pipeline, beyond this course. And then there's the deep learning on AWS class. And I believe there's exam readiness for machine learning. There is one other. Oh, practical data science with Amazon SageMaker. And then there's ML ops engineering on AWS, which is the class I teach the most frequently. And then the machine learning pipeline, which is the one that we are taking here. Okay. So be aware that there are tons of other classes that you can go from here. This tends to be the starting point. Either big data or this course tend to kind of lean you in at that point in time into deep learning, into practical data science on SageMaker, into the other classes. Okay. So with that being said, this is the goal. It's going to be super lean and super focused. The course is going to go lecture, discussion, some exercises, and then you're going to do a lab, and half the lab, you're going to do the experiences that we recommend, like learn about pre-processing, right? Learn how to train a model, that kind of thing. And then the other half of the lab, you're going to do what you did in the previous half. Now, don't freak out, because I'm just going to warn you, you're going to be messing around with machine learning. You're going to be touching SageMaker, you're going to be touching Jupyter Notebooks, and you're going to be messing with Python. And if you are like, Michael, I'm not sure that I'm well versed any or all of those, great. Don't worry. As long as you keep an open mind, just stay relaxed. We're actually going to give you the solutions to most of this. And so if you're an advanced, ML specialist and you're like, I really want to learn some stuff, you don't have to look at the solutions. If you're new to this, all you might do is look at the solutions and navigate that, because, this is all new to you. And so you've never used Panda for data framing. You've never used what all my friends jokingly refer to as Skittle. It's scikit-learn, right? Or Seaborn, or if you haven't used any of those like Python libraries, then you might just go straight for the solution. Okay, so just know that knowing all that stuff is not a prerequisite. This is really, like I said, a beginner's course for this. So basic knowledge of Python, how to create lists and arrays, and how to, can you read Python and edit it? It might be good enough for now, right? How to import libraries using pip. Yes, I hope you know some of those fundamentals, right? If you don't, we'll figure them out together, right? Basic understanding of AWS. Do you know what EC2 virtual machines are? Do you know what VPC networking is? Do you know what S3 bucket is? Do you know what a security group and a NACL is? They're going to assume that you know that. Again, if you don't, we'll help, right? But just all I ask is that you be patient with yourself, especially if you're on the kind of beginner end of the spectrum, okay? With AWS services, just breathe, be patient. We're going to figure it out. And then a baseline understanding of how to write code cells and markdown cells in a Jupyter Notebook environment. Yeah, don't worry. We're going to talk about that as well. But again, not only are there plenty of resources out there for you to use, but this is all, it can be as spoon-fed as you want it. It can be as hard as you want it, right? So it can be as easy as or as hard as you want it to be in this class. Okay. Now, I want to be clear about something. The one thing I cannot give you back is your time. I can give you back your money, your refund, all that stuff. But, just to jump ahead a little bit before we get into introductions, we're going to select and justify our ML approach. That's going to be primarily today. We're going to build, train, evaluate, and deploy and fine tune an ML model. We're going to apply the steps of the ML pipeline to solve the problem. And then we're going to describe best practices to like improve or, just improve, make it better, make the pipeline better. And then, identifying like the steps that we want to think about to apply it to real business problems. Business problems kind of being the source. Now, I just want to make sure I'm clear about this, is that the business problem is identified, aligned, and described at the very beginning of the process. We're really just checking alignment at the end, right? So I just want to make sure, that being said, is everyone in the right place? Is this the journey you signed on for? Okay. All right. Now I'm going to come back to the project goals for a second, but I'm going to come back to this because, thank you, by the way, for responding. This is what we're going to do next. And I'm going to pause the recording for this because not everybody needs to hear everything. We're going to pause this and then I'm going to resume recording when we go back to this. So general course outcome is, what you should understand and generally be able to do after completing this course. Now, I want you to know that if you're looking at your student deck, you're like, it doesn't really say that in my student deck, Michael. It says something different. I modified it because Amazon's statement was very like hard. Like, you should be able to absolutely do these things after the class. They didn't say absolutely, but it seemed to be implied. And it's the things that we looked at before we actually did basically our introductions, which is select and justify the appropriate ML approach to a problem. And let me qualify this a little bit. You should be able to start to define the problem. I've worked with teams where it took us 3 or 4 weeks to actually define. Like, we understand the business problem, but what's the ML approach, right? And then, sometimes we just pick an approach, do a little bit of a proof of concept with some data, again, to see how it responds and train the model and see if we're headed in the right direction. And then we might go back and retry like another model, right? Another approach. So just know that this is an iterative process. It's not like we have to have the answer before we can move forward. So I want to soften that a little bit. because many times we're going to be in a space of the unknown about how to solve this problem, and we're going to experiment to solve it, because that's what the scientific method is really about, right? Hypothesizing theories and then experimenting. Let's see if we can prove this. Let's see if we can repeat it. So building, training, of deploying, evaluating, and fine-tune an ML model. I know that sounds like that's like a level 10 thing, but we're really just going to stick our toe in the water. It's going to be levels 1 through 3, really. And then apply the steps of the ML pipeline to solve the problem. We're definitely going to talk about that. And describe best practices to create a solid ML pipeline. Oh, we're going to cover that as well. And then steps to apply to real business problems. Really what we're going to do is, how will you know that the model that you trained is fitting the outcomes that you want? Like how do we know whether or not we're getting real, like in a sense, predictions? Like what is our accuracy? What is our recall? What is our precision? We're going to talk about what are the concepts that you want to think about in order to know whether or not you're on target with aligning with the business problem you're trying to solve using the ML approach, right? So we'll talk about that. Okay. I think I asked this question already. Are you in the right place? You all said yes. So good. Okay, other things to note is that this class, and you pretty much have to choose it by the end of the day, probably in the morning, is that you have 3 possible projects that you as a student can work on. One is flight delays. And a lot of this is based on weather, but let me be clear, not major weather like hurricanes and stuff like that, but minor local weather, right? Which is still can be severe, but relatively it's local weather. Then we got a recommendation engine. So it's almost like you work for imagine you're working for Delta on the flight delay thing. On the recommendation engine, you're working for Netflix, right? So again, this is all based on Amazon.com data, but you're coming up with a recommendation engine to see what could I recommend to this person based on what they've seen in the past, right? And then we're going to talk about fraud detection. So in this particular case, you're trying to classify whether something is or is not fraud, with obviously a high degree of accuracy, precision, low bias, low variance, that kind of thing. Anyway, regardless, we're going to figure that out. But the fraud detection, so imagine like you work for a bank and he was trying to detect credit card, fraud. So flight delays, you work for Delta. Recommendation engine, you work for Netflix. Fraud detection, let's say you work for Chase, for example. Okay. And so you're going to get to look at the projects themselves generally, but those are going to be the 3 areas that you focus on. So one of these projects you're going to choose and you're going to stick with for the entire class. Now, I'm going to forewarn you that this class was originally designed back in 2018, 2019, with us all being able to see each other without making each other sick, unfortunately, because, COVID. So be aware that, there's supposed to be like a presentation part to this whole thing. And if you see reference to that, we're not doing that. Okay, we're not, because it just doesn't work in a virtual environment. What we will be doing though, is we'll be working together, supporting each other, answering each other's questions. And what we're going to do is that, and I usually experiment with this, is that we're going to work together in one space. Now, there are 21 of you, which is unusual. So the only thing that could happen is that if we find out there's too much kind of back and forth and it's overwhelming and distracting people, we might create 3 rooms, like breakout rooms, and have the flight delay room in there, the recommendation engine, and then fraud detection with another group. But in general, we're going to try and stick all together in the same room. And if it becomes really chatty and distracting, then we'll separate it out. That's only happened a couple of times. Mainly everyone ends up staying in the same room. Okay. So just know we're going to work on these 3 projects. You're going to work on it as a team, like in a sense, like individually, but with your peers to assist and help if you have questions. I'm a big fan of students answering each other's questions, because it also allows me to correct, test, and verify if I see someone answering someone else's question and it's not, accurate. It also obviously empowers those of you who have tons more experience in some of these spaces to support those who don't. And some of you have more AWS experience, so you can support the people who don't. And overall, the goal is to support learning. So we want this to be an open and safe environment. Okay. All right. By the way, you're going to get at least an hour every day to work on your project. So, okay. Now, project details. So with the flight project, you work for a travel booking site. I said Delta, it could be Expedia. Do people even use Expedia anymore? Priceline, whatever, right? So they basically want to let the customers know when their flights are going to be delayed due to local weather. That's what it should say, not severe, like national, regional weather. So you're going to basically use ML to identify whether a flight will be delayed by weather. That's it. Project details for the recommendation engine is basically you either work for Amazon Prime Video or you work for Netflix, and so you deliver on-demand video streaming. You want to basically create a recommendations engine, right? So you're going to use ML to do that. And then this one, you work for a multinational bank, let's say Chase. Over the last few months, there's been a huge uptick in credit card fraud, and so you want to be able to identify fraudulent transactions before they have a larger impact on the company. So to conduct the work for the projects, which by the way, does anyone have any questions past the preliminary exposure to the projects? Okay. So to conduct the project work, you'll use a handful of tools that are kind of enabled for ML workloads, specifically SageMaker, Python, and Jupyter Notebooks. So SageMaker, as you are probably aware of, is basically a cloud-based platform where you can build your ML models, you can train them, you can deploy them. And this can be used, by the way, for on-demand, one request at a time processing, or like real-time processing, or it can be used for batch processing if you just want to submit a data set and have it worked out. So why do we need the platform, by the way? It's each phase of this process, like the build, the train, and deploy, requires really a different kind of compute infrastructure, or a different approach to solving the problem, and honestly, a distinct set of skills. Sourcing data, cleaning the data, like in a sense, cleaning the data, pre-processing the data would probably be a better word to say it. Pre-processing the data, identifying dimensionality and what data is relevant, what data is not, converting, categorical data into, numerical of some, like all of those skills like are required. And some of it is as much of an art, especially when it comes to domain specific data, as it is in a science. Now we try to stick more on the science thing, but sometimes it's like you're going to need someone who really understands the context of the data, which is where like a domain expert comes in, as an example. But SageMaker provides all of the components needed to address that whole like build, train, and deploy kind of model, right? Now, I'm not saying that these tools all fit into distinct sections of that. They don't. All three of them work together to make this happen. So with SageMaker, you're going to use Jupyter notebooks in environments that allow you to create and share documents. You can share code and reports, and you can do data visualizations in the same space. So if you need to see like a confusion matrix or a heat map or whatever you need, you can actually do it from within the Jupyter notebook, and you're going to see that. And we're going to show you how to do that step by step. So with those complex workflows, you're going to increase both productivity and collaboration by allowing, all of this to happen in SageMaker. Now you're going to use Python. We're not using R or any other kind of language. I know that some of you are really sad. So and while you don't have to use Python, because like you could use a variety of other languages, Python, if you are not comfortable with code, is an incredibly great place to start. It's multi-purpose. I wouldn't say it's been geared for data science, but there's certainly a lot of libraries that have adapted it to data science, because that's not what it was initially created for. And Python is just simple to use, right? So, and you can use more than one language in the same notebook, by the way. So when collaborating with other people, like if you want to mix like R and Python together, you can. Let's see. Student guide, I just talked about. That's the one that's on bookshelf.vitalsource.com. There is a student project template, and there is actually a example project template. Let's see. I think I have links for that. Hold on. Where are you? Student project template. Here we go. Yeah. Student project template and example project template. Here we go. Okay, yeah, so these are templates, and let me open these up really quick. All right, so here's the student project template, and this is a little bit of an eye chart, so let me blow this up a little bit. I always forget that Word does not allow you to approach this with the same. Wow, that's really large. All right, so here's the project details, right? And so when you start stepping through like problem formulation, you know, exploring the data you have in pre-processing, doing the actual model training, model evaluation, it is good for you to take notes as you go along the way, right? For your student project template, it's just good, like to capture your thoughts. What were your assumptions? Did you drop data? Did you did you exclude data? Did you do imputation because you had gaps in your data, and so you did a mean imputation or some other kind of technique? It's good to note what you did to arrive at the outcome. Now, I know a lot of you think, well, I'm just going to rely on memory. And again, code will capture a tremendous amount of this for you. If you do it in a Jupyter notebook, you're going to have a lot of your methodologies captured, but you might not have the context or the justification. Could you put that in your Jupyter notebook? Yes. And you will see how to do that. But my point being is that it's just good to understand your methodology. If you want to repeat your method, you have to capture your methods. And if you decide to change your methods, you want to capture the changes, right? And it sounds like, why can't we just get in there and just mix it up, Michael? Because you want it to be reproducible. And again, putting it in code will make a lot of it reproducible, but it may not capture the justification for why you did it. And that could be important later on when you want to change something, okay? So this is the student project template. If you want to see an example project that's kind of like filled out, again, let me blow this up. Here's an example project. So here, this is where this is filled out, right? And this one's like a direct marketing campaign against like a targeted set of users. This talks about which type of like, binary classification supervised learning should be used, right? That kind of thing is all listed here. So this can be useful as a guide. And you're like, what should I be sticking in this template? So I would pull this back, make your own copy, make sure it's on your machine. Use it if you find it useful. If you're like, this is really just going to distract me, Michael, fine. But do note that you want to maybe then if you're not going to use the templates, you're going to be working in a Jupyter notebook that you're going to be uploading and downloading as you work through your projects. Make sure you stick your notes then in your Jupyter notebook, which is not a bad practice, honestly. It's probably the best place to stick it. Okay. So keep it in a separate Word doc if you prefer it there, or if you're comfortable with Markdown and just sticking your notes inside of your Jupyter notebook, you can do it there as well. Okay. But just to point out is that we won't be in a Jupyter notebook the entire time, so it's still useful to have a document like this. Okay. So between the student guide, which should have these slides, the student project template where you're going to take your notes, plus the Jupyter notebook, and of course the example projects, which you have as well, right? So by the way, those links I posted are actually in the student guide on whatever slide number this is, 23, I think it is. So you should be able to find it there as well. If you need it again, just let me know. Be glad to provide it. All right, here is in general what we're going to do. I don't want you to get hung up on this. Don't get wed to this. People are be like, Michael, it's day 2. Where's our first checkpoint? Please don't do that to me. We're going to adapt based on what questions people ask inside the class and challenges they run into. Okay. So do note that, for example, often, just to be upfront about it, is that, you won't actually like choose your product like in day 1. That didn't happen sometimes in day 2, because we're going to spend most of the day just kind of getting introduced to ML and to the ML pipeline, and then introduced to SageMaker. And so don't get all hung up on this, because there's plenty. We have baked in at least an extra hour a day, if not more, to kind of allow you to work out exercises and stuff like that. So we've got extra time in here just to make sure that we can be accommodating for, more time on labs or whatnot. Okay. But in general, this is what we're going to do, right? We will do the checkpoints, by the way. We will do a pre-assessment. You might notice there's a pre-assessment over there. And then we'll do a final assessment. Let me be clear about the checkpoints and the assessments. No one is looking at those. I can go look at them, but they're anonymous. So I just know in general how the class is doing. That information is not shared out with anybody. It's just purely for you to know whether or not what you knew at the beginning of the class and what you knew at the end of the class. That's it. Okay. So this doesn't get pulled down, captured, or shared with anybody. The assessments are totally for your learning, so you can challenge yourself. So let me just run through this in a little detail. And by the way, interrupt me at any time. I am looking at chat, so if you pop a question, I usually will respond. But please feel free to pop in any time if I'm just like talking. So obviously we're doing this introduction. We're going to do a pre-assessment here in a second. That's totally anonymous. You're going to take it. And then we're going to probably today, we're going to cover the introduction to the ML and ML pipeline. We're going to talk about SageMaker as a service, since that's our core service that we're going to spend almost all of our time with. And then you're going to do a lab, which is an introduction to SageMaker. And then we're probably going to end the day doing some exam prep, which I'm going to talk a little bit more about the certification. And by the way, if you're not interested in the exam at that point in time, just know that you can go take a break. And if you get interested later, you can watch the video on it if you want to. So your day could end at 4:30 if you wanted to. But you work for Booz, and I know this is part of Project Emergence. So you're probably interested in certification because Booz is interested in certifications. Now, after that happens, then we're going to talk about a little exercise. You're going to choose your project. So you're going to choose whether or not you're going to do the credit card fraud detection, the weather interference with flights, like tracking delays and stuff, and the recommender for videos, right? And then module 3 is us going to be talking about like problem formation. And again, these are mainly individual exercises, but you're going to have the support of the group and myself. And you're going to try and formulate your business problem based on, you know, the project that you chose. That's all day one. But I just, again, forewarn you, everything from exercise down, it's probably going to, the first exercise down, it's probably going to end up on day 2. That's usually how that rolls. Oddly enough, even if exercise goes into day 2, we end up probably sticking with the day 2 plan pretty cleanly. Sometimes module 5, the module training will go into day 3, but that is an aberration. That's not common. So we'll start, you know, with whatever we've got left over from day 1. Then we'll do the checkpoint, and then we're going to talk about data pre-processing, like, you know, how do you need to like shift your data to make sure that the data is good, there's no gaps, that your data is in the right formatting. How does SageMaker take that? Does it need to be in CSV versus protobuf? You know, those kind of questions. And then how do you accomplish that in code? Now, for those of you who don't spend a lot of time in Python, I think you're going to be shocked at how easy, for example, Python has made it for you to generate visualizations and process data and remove null values and, you know, compute, you know, means and stuff like that. Chris, I'll talk about that, but protobuf is a format, basically. It's a way of structuring the data. And you'll hear words like Parquet and ORC and all and CSV, TSV. So, you know, like CSVs and TSVs are comma separated values and tab separated values. It's just another formatting, but it's a little bit more complicated because there's encoding involved, which I'll talk about. There's some serialization, which again, we'll get to that, but so you'll know what protobuf is by the end, Chris. Just for right now, know that it is a way of basically structuring data into a format. Yeah. So checkpoint, data pre-processing, model training, we're pretty much in day 2, somewhere around that like kind of time frame. And again, remember either the end of each day or sometimes right after lunch, particularly on day 4, I'll cover the like exam stuff so you can have it. Day 3 starts with another checkpoint. And then how do we evaluate our models? How do we, like, you know, it's like, how do you know that your model is accomplishing the business goal and your success metric? Because just to be clear, your business goal and your success metric are going to be like distinct. Like the business goal, for example, may be like, you know, we want to make sure that we retain, no, we have customers consume relevant videos and increase, you know, subscriber consumption by, you know, 50% over a 3-month period. That's pretty good. So your ML success metric would be like, be able to recommend videos to relevant subscribers that are consumed, 80% of the time. Meaning you make a recommendation, and out of those set of recommendations, they click on that video and they consume it. And 4 out of 5 times when you present a recommendation to them, they're like, yeah, I want to watch that. And they watch it. I mean, that's aggressive, by the way, but like, that you could get there, right? That could happen. I've seen it happen. So how do you know that you've succeeded? Like, how do you know that your model is trained in such a way that it's not just memorizing the training data that it's seen before, and that it's learned enough about what the characteristics and components are that can actually analyze and derive? Because otherwise, I mean, we're asking these things to make predictions, right? To make inferences. Have you given enough data? Do you not have enough data? Does it have too much data? Has it memorized things? Like, how do you evaluate those from a numerical standpoint? Like, what's the math that we look at? And are there ways, for example, not just in pre-processing, but also in post-processing, where we can visualize the outcomes to get a better feel for whether we're on the mark or off the mark? So we're going to talk about all that. I know it sounds very abstract, and to be clear, you're going to hear me a lot of times say, well, it depends on what kind of problem you're trying to solve. And it sounds like a really like consultant's answer, but we're going to talk about some of the numerical, like the math that can be applied and some of the statistics that we can track to make sure that we're on target. Okay. Now, notice it says project presentations. Like I said, anything where it says project presentations or final share outs, you can just ignore those. I didn't remove them from the slides, but we're not doing that. Don't get me wrong. You can share at any point in time if you want to talk about what's going on inside your project or your thought processes. But we're not going to require you to stand up and publicly speak every single person about your projects, because one, it was really designed for a different kind of setup. Then we're going to talk about feature engineering, model tuning. For example, what if you need to do things to your data, like to like add features, do contextual additions, in code differently. Like, what if we need to do that? And then how do we tune our model? Like, what if we need to shift things like the rate at which it's learning, the increments by which it is taking in data and moving forward? What if we need to shift those kind of things? So we're going to talk about that. And then the next day, the final day, we're going to have a checkpoint, and then we'll do some feature engineering labs, right? So you can get a feel for what that looks like. And then we're going to end just by talking about model deployment. We're not actually going to do a model deployment, honestly, because it's just not that hard, especially with SageMaker, since it handles a lot of the abstractions for you. I will, though, very clearly in Modulate on model deployment, I'm going to talk very explicitly about the things that showed up on the exam around model deployment, so that you know the trips and the traps that can show up for that. Okay, like for example, when do you stick an API gateway in front of it? Can you stick an application load balancer in front of it? How do you get it to go faster if you want to like ingest or train data? That's a little bit not deployment, but like the difference between S3 and file mode and S3 and pipe mode. I'm going to talk about all that. So you might be like, Michael, I don't really know what that means, and don't worry, we'll figure it out together. And then last will just be the course closing. I tend to, by the way, close out the last day by having us do the exam prep after lunch, so that way when we're done with the final exercise and model and do the course closing, we can just be done. Most people's brains are burned by Thursday at 5 o'clock anyway, after 4 days of this. Okay. So the only thing that's really missing from this is the fact that we're going to be doing exam prep every day. Any questions about any of this? Any requests? Okay. All right. So we have a pre-assessment, and I'm going to combine it with a break. Oh, wait, sorry. I saw a note flash up, but I didn't see exactly what it was. Did anybody need anything before I move forward? Everyone's good? Okay. do note, by the way, that we actually have an assessment to do. Now, everyone remember, this assessment is for you. No one's going to look at it. Booz isn't going to see it, right? So I want to be clear about this. This is for you. This is totally anonymous, right? No one's going to see this. By the way, the only reason you're going to put my last name on here is so that I can find the things anonymously if I just want to see in general where you all are at. But otherwise, you're not associating any personal information to this at all. Okay. I just want to make sure that's clear. People get all tense and they're like, I'm about to be tested. Nope. Take a breath. No one's about to be tested. It's all good. Okay. Let me pause for a second and answer the question that Nick asked. So if you're a total beginner to ML, how long after this course could you take the exam and pass in an ideal world? So I'm going to talk about that from an exam prep perspective. So this class covers about 60%, maybe 75% of the material that you need to pass the exam. There's probably another like 25 or more that requires you to do the certification study guide and some other things. If you are a total beginner to ML, I'm going to say that the specialty exams do assume that you have some experience with ML, at least, somewhere between 2 to 3 years. And if you have like a degree, obviously, in mathematics and you've done problems at university level and research labs, then you could probably shortcut that. But it does assume some industry knowledge. So I would say, honestly, like anything, like you could end up passing the certification and not be able to do the job. So with this in particular, I'm just going to caution you that you probably want to spend a year, maybe 6 months, but probably more like a year, just crushing projects, manipulating and massaging data, and then, probably consider taking the exam. If you're really like serious about it and you can double down on it, you could shorten that time frame by just doing some ML projects and then, studying the material and then doing some hands-on labs and then, doing the practice exams, and you could pass the exam. Just to say this is I have had people within 6 months or less actually take the material and pass it. But they weren't really comfortable as data engineers. They weren't comfortable as ML specialists. They could do some things, but they weren't like fully comfortable in the role, and that might be good enough, right? So, to answer that, Nick, if you've never worked in any role with ML, it'll probably take you 6 months to a year, honestly. But again, if you have any experience or you want to accelerate that, any prior experience, for those of you, for example, who have been working as data scientists or engineers of some various types, ML specialists, just know that it's probably going to take you about 12 weeks to study. Now, can you go faster? Absolutely. I will explain my reasoning for all of that, but in general, it takes 60 hours of study for you to prepare for the exam. And oddly enough, I knew that already because I had passed it prior, and I averaged probably pretty close to like 55 hours of total study, which I tracked for me to pass it. And I, have had years of prior experience, right, with ML. So yeah, so if you're brand new, you can accelerate that, but on average it's 6 months to a year. If you've been doing ML for a while, it's probably going to take you about 60 hours of study to beyond this class to get ready. Okay. So, and Nick, you can go faster if you want to. So you can make it happen sooner if you need to. Okay. Yeah. All right. So let's talk about this pre-assessment. First of all, where is this pre-assessment? Oh, yeah, there we go. Okay. So 25 questions, 45-minute time limit. It's going to cover everything that we just talked about. So general things about ML, SageMaker, formulating the business problem, data pre-processing, training a model, evaluating a model, tuning a model, including feature engineering, and then deploying a model. So it's pretty much going to go through like the different sections that we're going to cover. Why do we want you to take this? Because you're going to be like, oh, I know nothing. Well, welcome to the club, because I feel like I know nothing every time I approach a machine learning problem. I feel like I'm starting over somewhere, right? So you just want to start becoming familiar with the topics in the course, understand where you're great and where you've got some challenges, and then create a benchmark to see what the difference is later. So remember how well you did, right? All right, so here it is. Here's the link, which I'm actually going to post in chat. That's right. Okay. And let me just show you this quickly. Is that you want to put Forrester, and I would prefer a capital F. I don't really care, but you're going to put Forrester in here, and then what's going to happen is that, and I'm going to give you a little preview. It's going to like ask you like a question like right off the bat. I'm not going to answer that, by the way. So you have an hour to do this, by the way, because I want you to take a break. So it's 10 o'clock right now. I want you to come back at 11. You're going to do the assessment for 45 minutes. You're going to take at least a 15-minute break. Okay. Anyone have any questions about this, about what we're doing for the next hour? Cool. I'm going to put up a little timer, actually, just so you know, like when we're coming back. But in general, we're going to be back at 11. Okay. So it's 10 o'clock now. I'll see you in an hour. So I'm not going to wish you good luck because it's an assessment. Go kill it or do horrible on it. Either way, it doesn't matter. It's just an assessment to help you out. Okay. So we'll talk in a bit. I'll stop recording and we'll catch up with you at 11 o'clock.